we want to be confident when it comes to the configuration of policy-based routing. And so we've got a good step-by-step here. First, we build our ACL, or ACLs. In this case, we're using named access list extended mode. So we do the command IP access list, which says, I want to build in a named access list. Of the extended variety, standard would only look at the source. And then we do PBR ACL. That is case sensitive, so that when we reference it down below, we have to make sure that it's character perfect, and you may just want to copy and paste that. The uppercase is a good thing. When we put in character strings in the Cisco iOS, such as the name of something like a route map or the name of an ACL, get in the habit, if you want to follow what most people do, get in the habit of uppercasing the whole thing with underscores or hyphens. That's up to you. And then it'll make it easier to read, because then we recognize that it is not a command or a keyword, it is the name of something. It'll stand out of a lineup. So we're not shouting, we're just making it easier to read. And then build your entries. And in named access list configuration mode, these are all sequenced. So the first entry that you put in would be the first and topmost entry of the access list. So here we're saying match or permit IP host. So this is the source address, because in extended access list we have source first and then destination second. So the source that we're considering is 192.168.110.10. And so let's say that's our server there. That server has that specific address. And we'll say this is our router. Then we build our route map, which is a construct that pulls in a few different things. We say route map PBR RP. Okay. Now, be careful with this. The syntax will work, but there's kind of there's something subtle going on here. And that subtlety is, if you build in a route map entry without a permit or deny and a sequence number, one will be built for you. So really this means permit 10. Deny sequences do exist in route maps. And if we do not match under a permit, we're routed normally. Which means if we match under a deny, or we are not matched at all, we are routed normally. So in this case, we have route map, PBR RP. The permit 10 is assumed. And then we go into the logic of this sequence. And here we have what we're looking for. Match IP address, referencing not an IP address. You cannot reference an IP address directly with this. You reference either an access list or a prefix list. And if you are matched, which means you hit a permit line of the access list, you then apply the set condition. And in this case, set IP next hop 10, 10, 10, 1. Well, let's build out what this might be looking like. I might have had a choice between these devices. And that might be actually, say, the bottom. Shows what this could be. And we'll do something very different. 72.16.1.1 on the other router. And let's say that our primary pathway is going through this top router with a different address. But if you're coming from this address that is referenced with this access list, I want you to route that differently. I want you to route it to the next hop router with the IP address set by my set command. I have to apply that on the inbound interface on this BR1. So this router would be, according to our example, BR1. So we'll put that right there. And we'll say that we have E0/1 there. So another host, let's just make sure we understand the impact there. We could have, let's say, a host device. And that host device is certainly going to have a different IP address. Let's just say it's 192.168, put it in a different subnet. That different host is going to be routed differently. Its traffic will go up to BR1 and go that way, whereas the host would go another way. And let's say this is both going to the internet, off to the right-hand side. Notice that we have applied the policy to Ethernet 1. We have to remember the policy needs to be applied to the receiving interface, and it is, in fact, good to know the syntax. It's easy to forget the application syntax for policy-based routing. So IP policy at interface level will get you to where you need to be.